Welcome to this hands-on exercise. In this walkthrough, we will perform binning of continuous data using Pandas. We will also visualize the results using Matplotlib. First, we load the dataset into a Pandas data frame. Then we explore the data. The head function shows the first 5 rows. The describe function provides statistical summaries, including the minimum, maximum, mean, and quartiles. Now, let's apply equal width binning to the age column. Equal width binning divides the entire range of a continuous variable into intervals of the same size. The bin width is calculated using a simple formula: maximum minus minimum, divided by the number of bins. For example, a range from 0 to 100, divided into 5 bins, produces intervals of 20 units each. Equal width binning is easy to use, but it can create sparse or empty bins when the data is skewed or contains outliers. In our dataset, ages are divided into 4 equal width bins of size 13. These bins cover the ranges 22 to 35, 36 to 48, 49 to 61, and 62 to 74. Let's check how many data points fall into each bin. As you can see, some bins contain more values than others. For example, 6 data points fall into group 1, and 4 fall into group 2. Next, let's apply equal frequency binning to the income column. Equal frequency binning divides the data into bins that each contain the same number of observations. Instead of using fixed ranges, this technique uses percentiles. In this method, each of the 4 income bins contains the same number of values. However, the ranges of the bins are not equal. For example, one bin might span from 35,000 to 48,000. While another might span from 150,000 to 200,000. This shows how equal frequency binning preserves equal counts, even when the data is unevenly spread. Now, let's visualize the original continuous data. This is the histogram of the age column. It shows how age values fall into ranges such as 20 to 30, 30 to 40, and 40 to 50. The height of each bar shows how many individuals fall into each range. Here is the histogram of the income column. This plot helps us see how income values are distributed and whether the data is skewed. Next, we visualize the bin data using bar plots. This bar plot displays the counts for the equal width age bins. You can see how some bins have more values than others. Here is the bar plot for the income bins created using equal frequency binning. All bins contain the same number of data points, because each bin is based on quantiles. Finally, we display both equal width and equal frequency binning side by side. This comparison helps us understand how each method shapes the distribution. Now, let's summarize what we learned. The pd.cut function divides continuous values into equal width intervals. The pd.cut function divides values into quantile-based intervals with equal frequency. Histograms help visualize continuous distributions. Bar plots help visualize the categorical bins created by both methods. Binning is a useful technique for transforming continuous features into categories. It supports analysis, visual clarity, and machine learning workflows.